You think you're touching this screen right now. Your finger is pressed against the surface. You feel the smooth glass, the slight coolness, the resistance. You're in contact with it. Your skin and the screen are touching. Physical contact. Matter touching matter. No, stop. Pull your finger back and look at it. Now press it against the screen again. What's actually happening there? What does it mean for two things to touch? When you say your finger is touching the screen, what physical event is occurring at the boundary between them? You think the atoms in your finger are making contact with the atoms in the screen. You picture them bumping into each other, pressing against each other, like two solid objects colliding. The solidity of your finger meets the solidity of the screen, and that meeting is touch. Wrong. Catastrophically wrong. Here's a question that should make your skin crawl. How close is your finger to the screen right now? You want to say zero distance. They're touching. The distance is zero. But think about what that means. Your finger is made of atoms. The screen is made of atoms. Atoms have a size. The electron cloud of an atom extends roughly 1 angstrom, about 1/10,000,000th of a meter. If the distance were actually zero, if your atoms and the screen's atoms occupied the same space, their electron clouds would overlap completely. They would interpenetrate. They would merge. They don't. They never do. No matter how hard you press, your atoms and the screen's atoms never touch. They never make contact. There's always a gap between them. Always. The sensation you call touch is something else entirely. And when you understand what it actually is, your concept of solid matter will dissolve. Let me tell you what's really happening. The electrons in your finger are negatively charged. The electrons in the screen are negatively charged. Like charges repel. When your finger gets close to the screen, the electron clouds stay open polis. All of the brighter figures subsetting on the side of the seals on the electrons. The closer they get, the stronger the repulsion. This is what you feel as resistance. This is what you interpret as touch. You are not making contact. You are being electromagnetically repelled. Your finger never touches the screen. It hovers above it, separated by a tiny gap, and the electromagnetic force pushes back against you. That push is what you call touch. Touch is not contact. Touch is repulsion. Think about that. You have never touched anything in your entire life. Not the ground beneath your feet, not the fork you eat with, not another person's hand. Every time you thought you were making contact, you were actually being held at a distance by electromagnetic forces. You are perpetually hovering, separated from everything around you by quantum mechanical gaps you cannot perceive. The solidity you feel is not matter touching matter. It's force fields pushing against force fields. But it's worse than that, much worse, because the electromagnetic repulsion isn't even the whole story. That's the obvious part, the part you might have heard before. The deeper truth is more disturbing. The real reason you can't touch anything has nothing to do with forces pushing you away. It has to do with the fundamental nature of matter itself. Your finger is not solid. The screen is not solid. Nothing is solid. Solid is a lie your brain tells you to simplify the world into something your ancestors could survive in. At the atomic level, matter is almost entirely empty space. An atom is a nucleus with a radius of about 1 femtometer, 1/1,000,000th of 1/1000,000th of a meter, surrounded by an electron cloud with a radius of about 1 angstrom. That's 10,000 times larger. If you scaled the nucleus up to the size of a marble, the electron cloud would extend about 100 meters in every direction. The atom is 99.9 trillion, 1999 billion, 1999 million, 1999,000, 1999,999% empty space. Your finger is made of these mostly empty atoms. The screen is made of these mostly empty atoms. When you press them together, you're pressing empty space against empty space. The only thing that exists in that space is quantum fields, the electron field, the electromagnetic field, the quark fields in the nucleus. You are not a solid object. You are a pattern of field excitations, mostly vacuum, held together by forces. And those electron clouds that define the boundaries of atoms, they're not solid either. They're not surfaces. They're probability distributions. An electron doesn't exist at a specific location in that cloud. It exists as a superposition of being everywhere in the cloud simultaneously. The boundary of an atom is not a hard edge. It's a gradual decrease in the probability amplitude for finding an electron. The electron could be found far from the nucleus with small but non-zero probability. The atom doesn't have a definite size. It has a characteristic length scale where the wave function falls off, but it never reaches exactly zero. So when your finger approaches the screen, the electron clouds don't suddenly collide at some defined boundary. They gradually overlap. The wave functions interpenetrate, and as they do, two things happen. First, electromagnetic repulsion. The electrons in your finger and the electrons in the screen all have negative charge. They repel each other according to Coulomb's law. The force increases as the square of the distance decreases. When the electron clouds overlap significantly, the repulsion becomes enormous. This is the force you feel pushing back against your finger. But second, and more fundamental, Pauli exclusion. Electrons are fermions. They obey Fermi-Dirac statistics. The Pauli exclusion principle states that no two identical fermions can occupy the same quantum state, not as a law they follow, but as a consequence of their wave function structure. If you try to put two electrons in the same state, their combined wave function is antisymmetric under particle exchange, which means it automatically equals zero. This generates what's called degeneracy pressure. It's not a force in the usual sense. It's a quantum mechanical consequence of the statistical properties of fermions. When electron wave functions overlap, the Pauli principle forbids them from occupying the same states. The electrons are forced into higher energy states. This costs energy. The system resists this increase in energy. That resistance is degeneracy pressure, and it's what makes matter feel solid. The sensation of solidity, the resistance you feel when you press your finger against the screen, is not matter touching matter. It's the Pauli exclusion principle, preventing identical fermions from occupying identical quantum states. It's quantum statistics manifesting as a classical force. Your finger doesn't touch the screen because touch, as you conceive it, doesn't exist. What exists is quantum mechanical degeneracy pressure plus electromagnetic repulsion, and your brain interprets that as solidity. You are not sitting on a chair right now. You are hovering nanometers above the chair, held up by the electromagnetic repulsion between your electron clouds and the chair's electron clouds, plus the degeneracy pressure from the Pauli exclusion principle. The chair is not supporting you through mechanical contact. It's supporting you through quantum field interactions. You have never sat on anything. You have never stood on anything. You have always been levitating, held at a quantum distance by forces, interpreting that situation as contact because your brain has no other framework for understanding it. Think about what this means. When you shake someone's hand, you are not touching them. Your electron clouds are approaching theirs, electromagnetic repulsion is increasing, degeneracy pressure is resisting further overlap, and the combined effect produces a sensation that your brain interprets as touch, but no physical contact is made. You and that person remain separate, isolated, held apart by the fundamental forces and quantum statistics that govern matter. You have never touched another human being. You never will. Contact is impossible. Every kiss is two sets of electron clouds repelling each other. Every hug is electromagnetic forces balancing at an equilibrium distance. Every moment you felt connected to another person through physical touch was actually a moment of mutual electromagnetic repulsion. Electrons' Warner is not ready, but present. The warmth you feel isn't the transfer of matter. It's the transfer of kinetic energy through molecular vibrations transmitted across the gap. The sensation of pressure isn't atoms pressing together. It's force fields pushing against each other. You live in a universe where contact is forbidden by the laws of physics. Not difficult, not rare, impossible. Matter does not touch matter. It can't. The very concept of touch, of one solid thing making contact with another solid thing, is inconsistent with quantum mechanics. Solidity is an illusion. Contact is a fiction. Touch is your brain's interpretation of electromagnetic repulsion and quantum degeneracy pressure. But let's go deeper. Let's ask why the Pauli exclusion principle exists. Why are electrons fermions? Why can't two electrons occupy the same state? Because of spin. Electrons have half-integer spin. Spin half in units of the reduced Planck constant. This isn't like a spinning ball. It's an intrinsic quantum property, a degree of freedom that has no classical analog. But it has profound consequences. Particles with half-integer spin are fermions. particles with integer spin, are bosons. And there's a theorem, the spin statistics theorem, that proves this connection is necessary for consistency with relativity and quantum field theory. Fermions must obey antisymmetric wave functions. This is not obviously, this is required by the mathematical structure of quantum field theory. When you exchange two identical fermions, their combined wave function must pick up a minus sign. That minus sign is what enforces the Pauli exclusion principle. If two electrons are in the same state, exchanging them does nothing because they're already in the same state. But the wave function must also pick up a minus sign from the exchange. The only way both can be true is if the wave function equals 0. Two electrons in the same state produces a wave function that vanishes. The configuration is forbidden. This is why matter is stable. This is why you don't collapse into a singularity. The electromagnetic attraction between your electrons and your protons wants to pull them together. Classical physics predicts that electrons should spiral into the nucleus and atoms should collapse. Quantum mechanics prevents this through the uncertainty principle, which keeps electrons from being localized too precisely. But what keeps the electrons in your body from all piling into the same lowest energy state? The Pauli exclusion principle. Each electron in an atom must occupy a different quantum state. The first two go into the 1s orbital with opposite spins. The next 8 go into the 2s and 2p orbitals. The next 8 into 3s and 3p. The electron configuration of atoms, the periodic table, the entire structure of chemistry, all of it is a consequence of the Pauli exclusion principle. All of it is a consequence of electrons being fermions. All of it is quantum statistics preventing identical particles from occupying identical states. And this is what prevents touch. When your finger approaches the screen, the electrons and the atoms on the surface cannot merge into the same states. They're already occupying the available low-energy states. Putting more electrons into the same region of space requires promoting them to higher energy states, which costs energy. The system resists. That resistance is what you feel. That resistance is what you mistake for solidity. You are not solid because matter is not solid. Matter is a quantum field configuration that obeys exclusion principles. The solidness you perceive is your macroscopic nervous system's interpretation of quantum mechanical degeneracy pressure. It's an emergent property that has no analog at the fundamental level. If you could experience the world at the scale of atoms, you wouldn't perceive solidity. You would perceive probability clouds and force fields and quantum statistics. Solidity only exists at the scale where you can average over huge numbers of atoms and treat quantum effects statistically. Now think about the forces involved. The electromagnetic force is strong, extremely strong. The force between two electrons at a distance of 1 angstrom is about 10 to the negative 8 newtons. That's tiny on a human scale, but enormous compared to gravity. The electromagnetic force is about 10 to the 42 times stronger than gravity. Gravity is essentially irrelevant for atomic scale interactions. Everything you experience as solid, as resistant to touch, as substantial, is electromagnetic. Every physical sensation you've ever had, texture, hardness, temperature, pain, is electromagnetically mediated. When you feel the smoothness of glass, you're feeling how uniform the electromagnetic repulsion is as your finger scans across the surface. When you feel the roughness of sandpaper, you're feeling variations in that repulsion as your electron cloud encounters varying densities of surface atoms. When you feel heat, you're feeling increased kinetic energy in the molecular vibrations of the surface, transmitted to your finger through electromagnetic interactions across the gap. When you feel pain, it's because tissue damage has triggered nerve endings that signal through electromagnetic ionic currents. You live in an electromagnetic world. Gravity keeps you on the planet, sure. The strong nuclear force holds the nuclei together, fine. But everything you directly experience, everything you can feel and manipulate and interact with, is electromagnetic. You are an electromagnetic pattern interacting with other electromagnetic patterns through the electromagnetic force. And none of those patterns ever make contact. Here's an experiment you can do right now. Press your finger against the screen as hard as you can. Feel the resistance. That resistance increases as you press harder. Why? Because you're pushing the electron clouds closer together, increasing the overlap, increasing the electromagnetic repulsion and the degeneracy pressure. The force curve is exponential. Small changes in distance produce large changes in force. There's no sudden transition, no moment of contact, just a smoothly increasing repulsion as the distance decreases. Now think about what happens at the atomic level. The atoms in your skin are vibrating thermally. The atoms in the screen are vibrating thermally. They're not stationary. They're oscillating around their equilibrium positions due to thermal kinetic energy. When your finger is touching the screen, what's actually happening is that the surface atoms of your skin and the surface atoms of the screen are both vibrating, and the average distance between them is determined by the balance between the electromagnetic repulsion and whatever external force you're applying. But they're never in contact. They're always separated by a gap, and that gap is fluctuating due to thermal motion. At room temperature, those atoms are vibrating with kinetic energies of about 0.0025 electron volts. The electromagnetic interaction energy at a distance of 1 angstrom is much larger, on the order of electron volts. So the thermal vibrations are small perturbations around the equilibrium separation determined by electromagnetic forces. The atoms are rattling in their potential wells, but they're not colliding. They're always held apart. This is true for everything. When two billiard balls collide, they don't touch. Their surface atoms approach each other. Electromagnetic repulsion builds up, and the balls bounce off each other. The collision is mediated by electromagnetic forces acting across gaps. The hardness of the billiard balls is the stiffness of the electromagnetic potential, how rapidly the repulsion increases with decreasing distance. Hard objects have steep repulsion curves. Soft objects have gradual repulsion curves, but neither involves contact. When you walk on the ground, you are electromagnetically levitating above it. The electrons in the soles of your shoes are repelling the electrons in the ground. The Pauli exclusion principle is preventing those electron clouds from merging, and that quantum mechanical repulsion supports your entire weight. You've never stood on solid ground. You've stood on quantum mechanical degeneracy pressure your entire life. Here's where it becomes truly alien. The gap between your foot and the ground, the distance you're actually hovering, is on the order of a few angstroms, a few 10 billionths of a meter. You cannot perceive this gap. Your sensory systems don't have the resolution. To your brain, there is no gap. You are in contact. But that's false. There is always a gap, always. And in that gap, there's nothing but quantum fields. The vacuum isn't empty. It's seething with virtual particle pairs popping into and out of existence, fluctuations in the quantum fields that pervade space, electron-positron pairs appearing for infinitesimally brief moments before annihilating, photons being exchanged between charged particles to mediate the electromagnetic force. The gap between your foot and the ground is filled with quantum field activity. It's not empty space. It's active space. Space where fields are fluctuating and virtual particles are being created and destroyed and forces are being mediated. And you're levitating above all of it, held up by the statistical properties of fermion wave functions and the strength of electromagnetic coupling, interpreting the whole situation as standing on solid ground, because your brain evolved to model the world at macroscopic scales, where these quantum effects average out into simple mechanical concepts like solid and contact. Now ask yourself, if you've never touched anything, what does that mean for your sense of self? Your body image is built from tactile sensations. You know where your body ends and the world begins because of touch. But if touch is electromagnetic repulsion, if your boundaries are defined by the limits of your electron clouds, then where exactly are you? Your skin is not a hard boundary. It's a gradual decrease in the density of your electron wave functions. At what distance does your body end and the air begin? 1 angstrom from the surface? 10 angstroms? 100? The electron wave functions don't cut off sharply. They decay exponentially, but they never reach exactly zero. There's a non-zero amplitude for finding an electron from your body arbitrarily far away. You're not confined to a specific volume. You're a probability distribution that has high amplitude in a roughly body-shaped region, but extends indefinitely in all directions with decreasing probability. You are not separate from your environment at the quantum level. You're all the same fields. The electron field extends through you and through the air and through the ground and through the entire universe. What makes you you is just a particular configuration of excitations in those fields, a pattern that moves through space and persists through time, but not a separate entity with hard boundaries. The boundaries you perceive are artifacts of how your brain processes sensory information. At the fundamental level, you're continuous with everything around you. This is not philosophy. This is physics. Quantum field theory describes all matter as excitations of underlying fields. The particles are not little balls moving through space. They're localized in space metaphysics, the bodies of gray metaphysics. Your body is not a collection of particles. It's a complex pattern of field excitations, and those fields don't have boundaries. The distinction between you and not you exists only in the macroscopic description, in the realm of effective theories that emerge when you average over huge numbers of quantum interactions. Touch was supposed to be the most direct, immediate, undeniable form of contact with reality. It's the sense you trust. Seeing can be fooled by illusions. Hearing can be deceived by echoes. But touch is real. Touch is physical. Touch is matter meeting matter, except it isn't. Touch is your brain's interpretation of electromagnetic repulsion and quantum degeneracy pressure. It's a computational construct, a user interface that evolution built to help you manipulate objects at human scales. The sensation of touch has no direct correspondence to physical contact, because physical contact doesn't exist. What exists is force fields interacting across gaps, and your nervous system translates that into the quale of touch, because that translation was useful for survival. You've been living in a universe where contact is impossible, interpreting electromagnetic levitation as solidity, mistaking repulsion for touch, experiencing quantum field interactions as physical boundaries. Everything you thought was real about the physical world, solidity, contact, boundaries, is emergent, approximate, macroscopic. At the fundamental level, there's only fields and forces and quantum statistics. No solidity, no contact, no touch. When Feynman explained this, he was clear. You cannot touch anything because touch as you conceive it is not a physical phenomenon. It's a psychological phenomenon, a perception your brain constructs from electromagnetic data. The physical world doesn't have touch. It has forces mediated by field quanta acting across distances. The sensation of touch is what those forces feel like from the inside when your nervous system processing the signals. This is not disappointing. This is magnificent. Your sense of touch is sophisticated enough to extract detailed information about material properties, hardness, texture, temperature, shape, from nothing but electromagnetic force curves and thermal vibrations. Your brain can distinguish salt from sandpaper based on subtle variations in electromagnetic repulsion patterns. You can sense temperature through the rate of thermal energy transfer across the electromagnetic gap. You can detect vibrations, pressure gradients, shear forces, all through the electromagnetic channel. Touch is not diminished by being electromagnetic. It's elevated. It's remarkable that you can construct such rich tactile experiences from such an indirect physical interaction. But you have to give up the illusion. You have to stop thinking of yourself as a solid object making contact with other solid objects. You're a quantum field configuration, electromagnetically interacting with other quantum field configurations across gaps you cannot perceive. You're levitating through space, held at a distance from everything by forces, experiencing that situation as physical contact because your brain has no other framework. The screen you thought you were touching, you're hovering above it right now, separated by a gap of a few angstroms, held there by electromagnetic repulsion and quantum degeneracy pressure. The chair you're sitting on, you're floating above it, levitating on quantum field interactions. The ground beneath your feet, you've never touched it. You never will. Contact is forbidden by quantum mechanics. You exist in a universe where matter is mostly empty space, where particles are field excitations, where boundaries are probability distributions, where forces act across gaps, where touch is electromagnetic repulsion, where solidity is a lie told by evolution to simplify the world into something you can navigate. The universe you actually inhabit is stranger and more beautiful than the solid, touchable world you perceive. And now that you know, you can never unknow it. Press your finger against the screen. Feel the resistance. That's not touch. That's quantum mechanics. That's the Pauli exclusion principle and electromagnetic repulsion conspiring to create the illusion of solidity. You're experiencing the fundamental forces of nature, translated by your nervous system into the sensation of contact. But there is no contact. There never was. There is only force and field and quantum statistics. You can't touch anything. You never could. Touch is the user interface. Quantum field interactions are the underlying reality. And the gap between them, the gap between your finger and the screen, the gap between perception and physics, That gap is unbridgeable. Not because we don't understand it, but because perception and physics are different kinds of things, and the relationship between them is translation, not identity. This is Feynman's answer. This is what physics reveals when you ask what touch really is. And once you see it, your understanding of contact doesn't just change, it terminates. Contact ends. What begins is a new understanding. You are a field pattern levitating through space, interpreting electromagnetic repulsion as touch, mistaking quantum degeneracy pressure for solidity, experiencing the universe through an interface that hides the true nature of reality behind comforting illusions of contact and boundaries and physical presence. The world is not solid. You are not solid. Nothing is solid. Solid is how quantum field interactions feel from the inside when you're a macroscopic nervous system. And touch is what it feels like when your fields meet other fields across gaps you'll never perceive, repelling each other with forces you'll never directly sense, obeying quantum statistics you'll never directly experience, all wrapped up in the sensation your brain calls contact, because that simplification helped your ancestors survive. You wanted to know why you can't touch anything. Now you know, because touch doesn't exist. What exists is electromagnetic repulsion and quantum degeneracy pressure acting across gaps. The touch is in your head, the gap is in the world. And you're floating through space, levitating on quantum mechanics, experiencing what physics feels like when translated into human perception. This is reality. This is your world. You're not touching it. You're experiencing it through forces. And that experience, that sensation you call touch, that's all you'll ever have. The gap remains. The levitation continues. Contact is impossible. And the universe doesn't care that this disturbs you. It's too busy being quantum fields interacting across space, indifferent to your desire for solidity. Welcome to the universe where touch doesn't exist. You've been living in it your entire life.